Alright guys, I want to look at one more interesting quadratic problem. Okay, it's solving as a system. So here we've got y equals 2x plus k. So I know it's a linear graph with a slope of 2, but I don't know what the intercept is tangent to y equals 2x squared minus 3x plus 4. Now, what we need to do is we need to find the place. Remember what tangent means? You better know what tangent means. Tangent means that it touches the graph in one place. Okay? Now, what we're going to do is we're going to end up setting these two equations equal to each other because we want to find the point where they're both valid. Okay? And so we're going to go y equals 2x squared minus 3x plus 4, and y equals 2x plus k. So we're going to say 2x plus k equals 2x squared minus 3x plus 4. Okay, now these two equations we're then going to put together. All right, so we're going to simplify. We're going to move things over. We're going to subtract 2x, and we're going to subtract the k. All right, so we're going to end up with 0 equals 2x squared minus 5x plus 4 minus k. Now, keep in mind that this equation right here, the 2x squared minus 5x plus 4 minus k, is not either of these equations. It's kind of the combination of those, right? Now, if I were to solve this equation, then it should give me the point or the 2 points or the no points where these two graphs cross. So think about this for a minute. If I had two graphs like this, right? So a quadratic and a linear. This would be a secant, right? Because it touches the graph in two places. That would be because when I factor this, I end up getting two different roots. Sorry, when I factor this one down below. If I get two different roots, then I'm going to end up getting two different intersections. Now what I want is for it not to intersect in two places, but for it to intersect in one place. Now, in order for me to only get one intersection here, what needs to happen? Well, hopefully you said that the discriminant, now remember in IB we use the triangle to represent the discriminant. The discriminant needs to be equal to 0 because when I do the factoring or when I do the quadratic formula of this thing right here, right? When I do the quadratic formula of that to get the two answers, the two roots, to find out the x values where this crosses, I only want one. And to only get one, then that means the plus or minus square root part of this quadratic formula, or the factoring, needs to give me 0 inside of there. So I add 0 to one side and subtract 0. So what we're going to do is we're going to go ahead and find the discriminant of this, which is b squared minus 4ac, and we want that to be equal to 0. So b is negative 5, so negative 5 squared minus 4 times a times c, which is 4 minus k, equals 0. So I've got 25 minus 8 times 4 minus k equals 0. Distribute the 8. You can move the 25 over to the other side as well if you want. Let's do that. Let's move the 25. Oh man, we're doing so much at once, Mr. Bauer. It's overloading my brain. So distribute this also. So we're going to have negative 32 plus 8k equals negative 25. We'll add 32 to both sides. We've got 8k equals 7. Divide both sides by 8, and we get k equals 7 over 8. Now when k is 7 over 8, that means our discriminant is going to be equal to 0, which means we're only going to get one root for this, which means there's only going to be one intersection place. Okay, remember the root of this is going to be the intersection, just like when we factor we get two different roots. So when k is 7/8, I'm only going to get one root, which then means that these two lines would have to be tangent. Cheerio!